Okay, we really don't need to do much more with this. It's fairly straightforward. I just want to make sure that we do enough examples to get you comfortable with the distinction between them and the notation. We are going to come back to using NPR and CR later in this unit. And we already actually have looked at it a little bit. If you think about our sequential dependent events, right? The probability that if we drew 4 cards out of the deck that they would all be aces, we kind of had this idea going on. There were 4 cards for the 4 aces for the first draw, 3 for the second, 2 for the third. So we were already kind of flirting with the idea of combinations and permutations there. And we will go farther with them in the future. I just want to look at 4 examples real quick here and discuss how each one works. So suppose we have 100 cars in the race. How many different ways can they come in first, second, third, and fourth? Is that going to be a permutation or combination? The order does matter, so that's a permutation. And that's going to be 100 P4, right? P for permutation, C for combination. And I don't have that. I'm not going to do it. You know how to put that in the calculator. If you don't, you need to go back to the last video or 2 and look again at how to put these in the calculator. You should get a relatively huge number there, something in the multiple millions range, I believe. How about the next one? If we've got 50 students and we need to pick 5 of them to be representatives on Student Senate, is that going to be a permutation or a combination? Well, all representatives to Student Senate are equal, so the order we choose doesn't matter. There's just going to be 5 students there voting on whatever Student Senate does. So that's going to be a combination. So you do 50 C5. And remember, combinations are a little smaller than permutations because ABC, CBA, ACB, etc., all the rearrangements count the same. So compared to this number here, we're starting with a much smaller group, and combinations or rearrangements don't matter. So you should get a much smaller number out of this one. How about if we have 30 people and we need 8 people from them to volunteer for a study? Permutation or combination? Order doesn't matter. It's going to be, this 8 people are just going to be participating as opposed to not participating. So that's going to be 30 C for combination, 8. Right? If the order doesn't matter, if you can rearrange them in any way you want, then order doesn't matter. It's going to be a combination. If the order does, permutation. Suppose we've got 8 people competing for something and we're going to give prizes to first and second place. Well, right there, the fact that there's first and second, that tells you there's going to be a permutation, and that's going to be 8P2, which is really easy to calculate. That's just going to be 8 choices for the first one, 7 choices for the second. So that's going to be not 72. 8 times 9 is 72. There are going to be 56 possible ways for that to happen. Okay. Next time, we're going to move on to the reason that we've done all of these permutations, combinations, and all of the probability that we dealt with in the previous lectures. We're going to be looking at probability distributions.